Welcome to Electronics Techie. So in this video we discuss about 8x1 marks using 4x1 marks and 2x1 marks. So here we can see there is a two 4x1 marks. So two 4x1 marks here you can see, and one 2x1 marks. By using this we can design one 8x1 marks. So here you can see there is a 4x marks. First there is a whole 8 inputs for 8x1 marks, but we are using 4x1 marks. So that's why first 4 inputs of 8x1 marks is going to be, so whole 8 inputs are there. So first 4 inputs are going to be 4x1 marks, and second 4x1 marks having another remaining 4 inputs of the 8 marks. So 8x1 multiplexer there is a 8 inputs. So first 4 inputs are going to 4x1 marks, and second 4 inputs are going to be second 4x1 marks. So in 8 multiplexer we know that 2 power 3 is equal to 8. So there is a 3 select lines in 4x1 marks. So there is a 3 select lines, S0, S1, S2. So one of the 2 select lines are going to connect to these 2 multiplexers. So same, the select lines of both the multiplexers is same, but the data is different for both the multiplexer, and another remaining select line is going to be assigned to the 2x1 marks. This is 2x1 marks. So we are going to design one 8x1 marks by using two 4x1 marks and one 2x1 marks. So it is our final design purpose. So here in this video, so I think you are clear. If you have any doubt about this particular diagram, you can comment on it, and I separately explain what is multiplexer, how we can and every diagram. But until now the main concept is about Verilog codes, and just overview what you are going to do. So if you have any doubts, you can comment it. So here you can see first this is our main thing. So we are using 4x1 marks and 2x1 marks. So this is our 4x1 marks and 2x1 marks. For that purpose we want to design first 4x1 and 2x1. Then we are go to the main code we are going to design, that is equal to 8x1 marks. So first I arrange it. So first what you are going to do, first you have to start with module. So here you can write 3 modules. One module is like for 4x1, and one module is for 2x1, and the final one is our 8x1 using 4x1 and 2x1. So here first you have to write for module for 4x1 marks. So that's why I simply write module name as marks 4x1, and there is a inputs and select line output. So this code is already defaultly I explained in the previous videos, but I explain again for understanding this video. So here you can see module, and it is followed by module name. So here we are only design about 4x1 marks only. So other than you can go to 2x1 marks. Then we are using these two, and we are going to design 8x1. So first you have to separately write the different codes for 4x1 and 2x1. So here you can see. So there the water. So our 4x1 is like that. So 4 inputs and single output. So we have 4 inputs for 4x1 marks, and there is a 2 select lines. We have 2 select lines. So that's why you can represent with like this. Input I of 3:0 of I means 3:0 means we already know 3, 2, 1, 0. So they are the 4 inputs and 2 select lines, 1, 0. So they are the 2 inputs of select lines. So there is only single output, so I represent with out variable. So it is performing always block, so that's why I represent the output as reg data type. So what is the importance of reg and what is those all are we already discussed. If you don't watch, go to back and then watch that what is the necessary of reg using here, then you can understand correctly. Until now here we are going to move, and always keyword is like whenever you are going to change any particular thing, now block is going to be executed. So when it is going to execute at the rate, so sensitivity list, it is our sensitivity list. So inside if you represent star means the star represents the whole inputs. So what are the inputs we are going to give in this particular, we are going to use in this particular designing. So when there is any one change in particular thing, any select line or input, the output will going to be affected. So that's why you are represent with star. If you want particular thing, so whenever the select lines is going to be going to change, then only my always block is going to be execute and output will be update. Then we can simply represent inside the bracket as S. So whenever the select line is going to be changed, then only our output will going to assign the particular thing. Otherwise you can simply write star. So when there is a multiple statements, you are going to use begin keyword. So there is a here we can use case statement. So what is the case statement? How you can use, already we discussed. So I simply overview here. So case is nothing but it's like any condition. So here it's like whatever the condition you want to select for the whole thing. So you can write case simply bracket of s. So the values of s you are going to give inside in this case block. So here you can observe inside the class you are going to give the values. So what are these values? So it is the value whatever write the variable inside the bracket. So what is written here s? So s is of 2 bits. So that's why 2 tick mark b. So different values. So 2 variables means so 2 bits means you get 4 combinations 0 0 0 1 1 0 1 1. So for 4 combinations we are going to assign different inputs to the out. So for select line is 0, then I of 0 is going to assign to the output. So if select line is equal to 1, then I of 1 is going to assign to the output. Like that, here you can write the code here. So default, if you don't have any, if you don't give any these combinations, and defaultly, if you don't give any combination, defaultly takes as a don't care condition. So you can stop this case or end this case by end case, and begin will end with end keyword. So module is end with end module. So it is our 4 by 1 mux. So next we are going to design the 2 by 1 mux. So here also you start with module and end with end module. So you can write a module name here. So for 2 by 1 mux there is only 2 inputs, 1 output. So 2 inputs, what are the 2 inputs? I0 and I1. And there is only one select line in 2 by 1 mux. So you simply write 1s and output will be reg data because we are using always block. So that's why I represent output as reg data type. So always at the rate star begin. Here if the select line is equal to 0. So if the select line is equal to 0, our output will going to assign I0. If the select line is equal to 1, our output will going to assign I1. So you can simply write the if else statement here, and begin will end with end, and module is end with end module. So until now it is about how to design 4 by 1 and 2 by 1. It is already a separate video for particular these codes, but again I do explain because if someone are going to watch this video for particular 8 by 1 mux using 4 by 1 and 2 by 1, so if they are difficult to go back and then search for that video. So that's why I simply overview this. So these two codes are already discussed in previous videos. So here it is our main thing. So what is the purpose of this main is, this is the main code here. So module, so wait, I will erase this, then you can understand properly. So I think it's fine now. So it's clear. So here you can start module. So end with end module. So wait. So module, sorry for the delay. So module and followed by module name. You can write any module name here. So here I write module mux 8 by 1 underscore I using underscore 4 by 1 like that. So for 8 by 1 mux you all know about, for 8 by 1 mux there is a 8 inputs. So for followed by I0 to up to I7 there are the 8 inputs and single output. So you can must remember that there is a multiple inputs for multiplexer but only single output. So that's why you can simply write 8 by 1 means 8 inputs and single output. So what is the power? 2 power 3. So that means we are going to assign 3 select lines. We have 3 select lines here. So 3 select lines. So that's why I represent with 2:0 of s. So output will be we can represent with out variable. Here we don't use any always block. So here you can observe there is no always block. So that's why you don't represent output as reg data type. When you are going to use any always block, then you can go to assign the reg data type for output variable. So why? Here we are going to connect this value. So here you can see this is one output, this is one output, but it is not our final output. So no use of these particular values to store. So you simply connect this output to 2 by 1 mux input. So this output to again another input to the 2 by 1 mux. So just we are simply use some wires here. So no need to store that. So that's why you simply represent with wire data type. So wire 111 222. So here you can write this wire name is as 111. This wire name is as 222. Simply use for connecting purpose. So how you are going to connect mux 4 by 1? So why you write like this means, so when you are going to use this module in this particular module, so you are going to instance. So you have to connect this 4 by 1 with 8 by 1. So you have to go into instance. So that's why you write the module name which code you are going to instance here. So that's what are the code I want. So 4 by 1 mux. So that's why I write what is the module name. As it is you can same exactly you can write that module name and followed by one instance name. You can use any name here. So then followed by what are the inputs that are going to 0 here. So for suppose this is I of 0, I of 1, I of 2 and I of 3, I of 4, I of 5, I of 6 and I of 7. So this is our 8 by 1 mux input. So I of 0 is going to connect like this. So next 4 inputs are going to second mux. So see here in the code, so I of 3 is to 0. First 0 to 3 are going to give to first mux, and next 4 to 7 are going to give, see here 7 is to 4. So this go to second 4 by 1 mux. So select lines. So both the select lines are same here. So you can observe here, so BC means here represent BC. So here you can represent I of S of 0, S of 1 in code. S of 0, S of 1. So same select lines. So in the code also for 4 by 1 mux, so both the select lines will be same. So what you are going to, then output will be, it is a W1 wire. So this output wire is named as W2. So you can simply write W1, W2. So now what you are going to give, so these W1 to 2 by 1, these W2 are to go 2 by 1, sorry, 1. Wait 1 minute. So here you can observe, this is the W1, this wire is W1, this output will be W2. So this W1 is going to 2 by 1 mux, and this W2 is going to 2 by 1 mux. So here you can simply write W1, W2. There is a select line. So what is the select line? Different from this. That is S of 2. So S of 2 is our select line. So simply write, and there is a output variable. So it is our final output. So end module. So that's like this you can going to design the code by using 4 by 1 mux and 2 by 1 mux. You are going to design the 8 by 1 mux and end with end module. So it is our test bench code. So for writing 8 by 1 mux, so that's why I can simply followed by module name. If you are beginners, the frequently doubt will going to, there is a 3 modules. So for which module you are going to write the test bench? So it is a frequent doubt. So you don't know there is a 3 modules. If you are a beginner, you don't know there is a 3 modules for what, or for what module I are going to write a module means. What is our main code? So this is our main code. So you don't write test benches for instance modules. So it is our for using these modules in this inside this block. So no need to write test benches for these two. We are simply write the final main block. What is our main purpose? So here in this code, the main purpose is 8 by 1 mux. So designing 8 by 1 mux. So for designing 8 by 1 mux, we are going to use 4 by 1 and 2 by 1. So it is not our main one. There are instance. So our 8 by 1 is our main thing. So we are going to write the test bench code for 8 by 1 only. So 8 by 1 underscore TB. So what is our inputs? Here the inputs are represented in reg data type. So outputs are in y data type. So we have to instance the design code in the test bench code. So that's why follow the design name, design code module name, and followed by instance name. There is a port connection. So every video I say that the syntax of the test bench code is similar for everything. No need to bother about what is test bench code, and it is like unique like that. So syntax is similar. The only input combinations is different. So these are our input combinations. So input combinations, so are giving you can give any different type of inputs. So no need to give any particular truth table like that. You just verify whether your function is correct according to a truth table or according to your function, what is your design, so output will be correct or not, like that you just simply check. So no need to give particularly 1. So first they give 1, second they give 0, then you also go to give I is equal to 1 and I, no need to do like that. So you can give I is equal to 0 first and I is equal to 1. So what you are going to check for I is equal to 0, what the value is going to assign. So I is equal to 1, what is the value, like that only you check. Here you can give I is equal to 8 bits. So not only give this same value, you can give another value, another select lines. So you are cross check whether your performance of the 8 by 1 mux is similar to a truth table and what you are going to design is correct or not. Just simply check that only. So /5 is our delay. For different combinations you are going to give some delay between this, and finish keyword is used to, this keyword is going to use stop the simulation. So for particular thing, at the point of time you want to stop the simulation by using this finish keyword, and then these 4 lines, every time I say these 4 lines are going to use further generate the waveforms and end module. So this is our final output waveform. Here you can see that. So our final output waveform is like that. So here first we are going to see this line. So when you represent this line, so those values are going to see, you can see in this row. So the what is the select line 4? So 4. If the select line is equal to 4, so you know the truth table first. So how is our truth table like? So here I draw the truth table. So 0 0 0 0 0 1 and 0. So there is a 3 select lines. So like that we are going to 4 means 0 1 1 and 1 0 0. These are 4 and up to 7. So I of 0, I of 1, I of 2, I of 3, I of 4 and so on, I of 7. So for select line is equal to 4. This is our S0, S1, S2. So it is our decimal equivalent is 4. So select line 4 means I of 4 is going to assign to the output variable. So cross check whether select line is equal to 4, output variable is I of 4 or not. So he see in the video. So see in this waveform. So select line is equal to 4. So I of 7 value, I of 6 and I of 5, this is 4. So I of 4. So I of 4 is going to assign to output variable or not. For better understanding, I give C. If I of 3 is equal to 0, then you are getting confused whether I of 4 or I of 3 is going to assign to output variable. For that clarification only, I simply give only one bit, that is I of 4 only I give 0. Then you can properly understand only I of 4 is going to assign to the output variable. Then our function is correct. So what the code we are write is correct. So like that you can cross check according to your tutorial. Here you can see what is our select line 4. So I of 4 going to be assigned. If the line is moved to this space, you double click here. So this line will going to assign. The values are going to assign here. Then again you cross check what is your select line. The particular input is going to assign output or not. If it is assigned, so your code is correct. Otherwise, you can cross check whether your code is correct or not. If you have any compilation errors, any doubt, don't hesitate to ask in comment section. So until then, it's our code, and in next video you can go to some other topics. So if you want any particular code on this Verilog also, you can comment on it. First I do that for you. So thanks for watching. Until then, bye.